Welcome to Spring LIB.
All right, we have got some mass spec data, and we've got a peak at 50 with relative intensity 100, a peak at 52 with relative intensity 31, and then way down here at 15, we've got a little tiny, it's really tiny. Okay, so what does this look like? To me, well, the first thing that pops out is these two peaks, right? We have essentially a 3-to-1 ratio between what you might consider our M and our M plus 2 peaks, right? And that looks like chlorine, right? Remember, whenever we see this 3-to-1 ratio of our parent ion and the parent ion plus 2 peak, that's what we expect from chlorine, because chlorine exists of the isotopes chlorine 35 and chlorine 37 in a 3-to-1 ratio. That 3-to-1 ratio then matches the 3-to-1 ratio in intensity here, and the mass difference of 2 matches the mass difference between the two isotopes of chlorine. So we're looking at something with chlorine. Something else that sticks out to me is this peak of 15. If you recall, a peak of 15 typically corresponds to a methyl, right? This always 15, right? So just based on this data alone, I would suspect then that we have methyl chloride. That is H3C, Cl, right? Here's the 15, here's the 35 or 37, depending, which would give a total mass of 50 or 52 if, right, depending on whether it's methyl chloride with chlorine 35 or methyl chloride with chlorine 37.